Hi, we're now looking at a question on vertical motion under gravity. So you'll have a particle that's moving with a constant acceleration, g, due to gravity. And this acceleration has a numerical value for Cambridge of 10 meters per second per second. As the acceleration is constant, the uniform acceleration equations, or SUVAT formula, can be used. When solving one of these questions, you must choose the direction, upwards or downwards, to be positive, and that will affect the acceleration. Keep in mind, when a problem involves upward motion, like the next example, the acceleration is, of course, always downward. So a ball is projected vertically upwards at a speed of 14.7 meters per second from a point which is 49 meters above the ground, and we're going to model it. And we're looking for the greatest height first of all. So we have three parts to this question. Part A, we're going to draw a little sketch as always and write out our little SUVAT detail. So bear with me here with my little picture. So we start at 49 meters, not literally, at some point, and we know that it's going upwards. And we go back down to the earth, of course. So we'll put in our little points here. I'm going to make the upward motion as positive because that's where we're going. So I've wrote that in there on the left hand side. Another detail that you should remember with this kind of question, when it's a parabola like this, is that of course your velocity will be zero at the greatest height. Keep that in mind. The displacement is not 49, we don't know that yet. Initial velocity is 14.7, velocity is 0 as I said, and our acceleration is minus 10. So minus 10 in this case. We don't have to think about any time, so that should give you an indication of which of the formula we're going to use. And so which one does not have the letter t in it. So v squared equals u squared plus 2as. Plug in your values and you'll find the value of s. That'll be our first part, more or less completed. So get your calculator out and you'll get 10.8 meters. Now the greatest height is not 10.8 meters, it's 49 plus 10.8, which is approximately 60, it's 59.8 meters. And that's our greatest height, that's part A. Part B, the speed with which the ball first strikes the ground. Keep in mind, you might think that it equals 0 when it hits the ground. We're kind of not doing that, it's not exactly what that means. It kind of means like just before it hits the ground, what would have been the velocity. So it's not 0, it's just before. Once again, you can look at your SUVAT. You have S in this case is 49. Initial velocity is minus 14.7 because I'm going to choose the downward direction as positive. I want you just to have a look at that in isolation as well yourself as an idea within these questions. You can do it either way you want. Just make sure you're consistent in your own approach. So SUVAT, S is 49, U is minus 14.7, V we're looking for, A is 10 in this time, and T, I'm going to have to find that as well at some point. I can see that for the third part. So we found V there, we put it all together, we got 34.6 meters per second. Positive, of course. Just redo the SUVAT now. You could have done SUVAT 3 times if you want. It'll be the same for the third part there. So the total time we're looking for from when it gets thrown, projected, and lands on the ground. So this kind of topic would also be called projectiles if you come across different types of questions. We're not using v squared, we're going to use our most commonly used one. I think s equals ut plus half at squared. So 49 is equal to minus 14.7 times t plus 1/2 10 t squared, and you're going to get a quadratic, which you'll definitely have to use the quadratic formula for. You could use to complete the square, but use your calculator. Always use your calculator in this exam for any shortcuts. You should get t is approximately, you'll have to round up. T will be approximately a negative and a positive number. T is equal to, let me look. So 5t squared minus 14.7. So plug in your formula, minus b squared, minus b plus or minus root b squared minus 4ac over 2a. And you get t is equal to minus 2 and t is equal to 5. So if you think about it, our answer is definitely going to be 5. So that's our time, our total time. Just as a little side note, where does that minus 2 come into it? What's that even mean? If you look at our graph, as you draw it again here, if you actually have a look at your diagram, the start of that loop going to the ground is 5 seconds. And then the rest of it that we didn't need, because we started from 49 meters up, is where that 2 seconds is as well. So if you just think about it like that, that's where that came from. And that's pretty much that question. Just be careful of, you have to choose the direction it goes in. So test it out with a few questions and do it both ways. You'll see that it works out. But find your consistent approach for yourself.